This is another video on center of pressure chapters. The question here is about finding the tank sounding level. So most of the questions are where sounding is given, but we have to find the center of pressure. But in this question, center of pressure is given, and we have to find the sounding level. So this is a different approach here, different procedure. So we should be aware of this because this is from past MMD papers. Rectangular bulkhead is 12 meters broad and 8 meters deep. So this is a rectangular bulkhead which is 12 meters broad and 8 meters deep. Tank contains liquid and center of pressure is 3 meters above the bottom of bulkhead. So this is the bottom of bulkhead, and from here the letter marked Z. Z is showing the location of center of pressure, 3 meters from bottom of bulkhead. Calculate sounding of the tank. So here the approach will be, first of all, we have to find where is the liquid level. Is the liquid level below the tank top, or is it just at the tank top, means the tank is just full, or the liquid level is above the tank top, or that means the liquid is in the sounding pipe above the tank top. So that's very simple to find. The approach will be, first we will assume that tank is just full, and then we will find what will be the center of pressure. What would have been the center of pressure, location of center of pressure, if the tank was just full, means water level, the liquid level was at the tank top level. And then we compare that our answer with the center of pressure given in the question. That will tell us whether the tank is just full or the liquid level is above the tank top or below the tank top. Okay, let's see. See, this diagram is a rectangular tank top and is 12 meters broad. Height is 8 meters total. Center of pressure is 3 meters from the bottom. So in other words, is 5 meters below the tank top, because total is 8 meters height. So center of pressure is 5 meters below the tank top. Where is the centroid of this rectangle? Centroid of a rectangle is always halfway. So it's 8 meters deep. Total depth is 8 meters. Halfway will be 4 meters from tank top. So 4 meters below the tank top marked as G. That is the centroid of this rectangle. And 5 meters below the tank top is the center of pressure located. 3 meters from bottom, so 5 meters from top. Now, let's see, how do we know whether the liquid level is above the tank top or below the tank top? So let's find the depth of center of pressure, assuming the tank was just full. So if the tank was just full, that means the liquid level was at the tank top surface. The liquid surface was aligned with the tank top. So what will be the moment of inertia about the water surface in that condition when the tank was just full? So theorem of parallel axis says that if you know the moment of inertia about the axis passing through the centroid called IgG, this is axis passing through centroid. If we know the moment of inertia, then if you want to find the moment of inertia about any other axis which is parallel to the axis passing through the centroid, we have to add area multiplied by distance between the two axes, square of the distance between the two axes. One axis is passing through the centroid, and the second axis wherever is the liquid level. So in our case, we are assuming the tank is just full, so the liquid level is at tank top. So what will be the moment of inertia for the a rectangular shape above the centroid, above the geometric center. That's LB cube upon 12. In this case, L is the breadth and B is the height, the depth. So it's BH cube upon 12. Okay. So this is the centroid, and this is the moment of inertia about the axis passing through the centroid, BH cube upon 12. Then area of the rectangle, because this area is supposed to be area of the immersed surface, and we are assuming that tank is just full. So the whole of the tank is immersed. So the area is breadth into height, the rectangle area of the rectangle. So complete area we have to take because the tank is just full. And what will be the d square? D is the distance between the two axes. One axis is passing through centroid, and the second axis is at the water level. So in this case, the second axis is at the water level, which is at tank top. So, and the centroid of the rectangle will be at halfway. So it will be h by 2. Okay, the distance between the two axes will be half of the height because it's a rectangle and we are assuming the water level is at the tank top level. So it will be h by 2. The d will be height, half of the height, total height, and square of it. If you simplify this, it comes out to be h cube upon 3. This is also a standard formula when you have to find the moment of inertia about an axis which is at the tank top level. But it's okay, it just takes one line to find out bh cube upon 3. You can remember it also. So this is the moment of inertia above the water surface, Ws, assuming that the water surface is at the tank top level. So what will be the center of pressure in this case? The depth of center of pressure from water surface, COP from water surface. The formula is moment of inertia about water surface, water level upon immersed area into d. D is the distance between the centroid and the water surface. So moment of inertia about water surface, we have just found bh cube upon 3. Bh cube upon 3 is there. Area is b into h, breadth into height of the rectangle, and d is the distance between centroid and the water surface. So that is halfway, 4 meter. So this comes out to be, if I just simplified h square upon 12, height is 8, 8 multiplied by 8 upon 12, and it gives 5.33 meter. So now this would have been the depth of center of pressure below the water surface if the tank was just full. But center of pressure given in the question is 5 meters below tank top. So that means the liquid level is further up. Center of pressure is further up. So it's 5 meter means it is further up. In other words, the liquid level is above the tank top. That's how we argue about it. So this means tank is pressed up above tank top and liquid is in the sounding pipe. So let that head, when the liquid is in the sounding pipe, is called head. So assume that head of the liquid is x meter above the tank top. So x is the distance between the water surface in the sounding pipe and the tank top level. Okay, x meter is the head. It's called head of the liquid. So let's assume this is x. So now we will find the what will be the moment of inertia and the center of pressure. So what is the depth of center of pressure now below water surface? X plus 5. It is 5 meters from tank top because 3 meters from bottom, so it's 5 meters from tank top level and plus another X meter in the sounding pipe. So the depth of center of pressure below water surface, which is in the sounding pipe and above the tank top, will be X plus 5. So X plus 5 is the depth of center of pressure below the water surface, and the formula is moment of inertia about water surface I upon area into D. D is the depth of the centroid from water surface. So I about water surface is IgG plus AD square upon AD, same parallel axis theorem. So X plus 5 is equal to IgG of the immersed surface is BH cube upon 12. IgG is moment of inertia above the axis passing through centroid. So the standard formula LB cube upon 12 means BH cube upon 12. The whole the water liquid is above the tank top. So the complete bulkhead is immersed. So we will take BH cube upon 12 plus area of the bulkhead which is immersed B into H. Now the D. Now the D will be different because D is the depth of this centroid from water surface. So depth of the centroid from tank top is 4 meters, but the water surface is X meters above the tank top. So D is the depth of the centroid from water surface will be X plus 4 squared. Divide by area immersed. Area immersed is again breadth into height of the bulkhead, and D. D is X plus 4. Simplify this, cross multiply and simplify. X plus 5 is 12. 12 is the breadth of the tank top into 8 cube, BH cube upon 12, which cancels out, plus 12 multiplied by 8 into X plus 4 whole square upon 12 into 8 is the area and X plus 4 is the D. So further simplification is all, you will get a quadratic equation here, but don't worry because the x square part will cancel out. If you open all the brackets, make a cross multiplication and carefully multiply the brackets, open up the brackets, you will see that the square part 96x square and x square will both cancel out, and then there is a simple equation for x. 96x is equal to 128. X is 1.33 meter above tank top. So this, you remember, this x was the liquid level above tank top in the sounding pipe. So it is above tank top 1.33 meter. So what is the total sounding? Sounding is from the water surface to the bottom of the tank. So the total height of the tank is 8 meters and x is 1.33 meters above the tank top. So 8 plus 1.33 will give you 9.33 meters. This will be the sounding from tanks from the water surface to the bottom of the tank. So this is this procedure, because if you have not done it before and you encounter this question in the exam, it will take some time before you can think about how to go about this. So it's better that you have practiced this kind of question where you have to find the sounding of the tank. Okay, thank you very much. And I'm also soon after this video will be uploading video on vertical ordinates. We already did one video on horizontal ordinates of the curved areas has been loaded. So another one will be vertical ordinates, and there's one more where we have a composite surface. Means the bulkhead consists of a triangle and a rectangle. That also I have from the past MMD papers. So one after this, there will be another 2-3 videos only on the center of pressure because there are several variety of questions on center of pressure. So I thought of uploading one video of each variety. Okay, thank you very much.